So two sample t-tests for the difference between two means. Usually the samples are small and sigma 1 and sigma 2 are unknown. Unlike section 8.1 where sigma 1 and sigma 2 were known, but we ended up using the z-test instead. So we use a t-distribution in this section. In the previous section, we used a z-distribution. What are the conditions of the two sample t-tests? They're very easy to verify, guys. Sigma 1 and sigma 2 are unknown. The samples are random. You can see right here. And difference between, okay. The samples are independent and the population are normally distributed, or the sample size must exceed 30. Okay. Now, how do you state the null and the alternative hypothesis in this section? It's the same thing, guys, as the previous section. Either you're going to have a mu1 equals a mu2, and then a mu1 not equal to mu2. That's a possibility. And I'm very sure, guys, you should know the rest. I hope that you do know the rest. Will be mu1 less than or equal to mu2. Mu1 is bigger than mu2. That's an option. And the last option, so when you do a question from this section, guys, first of all, select either this or that or this one. Now you ask me, how do I select which one? How do I know which one is the correct one? Whatever it says in the problem, just follow it and see which one will match, just with what you want. Okay. Now, verify that sigma 1 and sigma 2 are unknown. Verify that the samples are random and independent, and verify that the populations are normally distributed or the sample size are 30 or more. How do you proceed with the test, guys? Just like in previous chapter and the previous section. State HO and HA and identify the claim. I want to add here, identify the claim as well. That's important. Calculate the standardized test statistic T. It was called Z in the previous section. Calculate the p-value. Make a decision to reject or fail to reject HO. Interpret the decision in the context of the original claim. Now, this is an additional feature that when you use a calculator, you have to be aware of. There is a feature, a question called the pooled yes or no when you use your calculator for the two sample t-test. We will use yes when he tells us in the question that we assume that the population variances are equal. We make this assumption. It will be given in the problem. And if he tells us that we assume if the population variances are not equal, we will use no for pooled. And based on your decision, yes or no, the test statistic and the p-value will change, guys. So that's very important. So the population variances are not equal. I know it's not making sense now, but when you see it in action, you will know what I'm talking about. But remember, yes, if he says in the question, assume population variances are equal. No, assume population variances are not equal. Let's do a question right away. So let me take you to a complete question and you will see, guys. There you go. There's one. Let's do it together. The results of a state mathematics test for random samples of students taught by two different teachers at the same school are shown below. And actually, it shouldn't be a $sign here, just a score. Can you conclude that there is a difference in the mean math test scores for the students of the two teachers? So we have teacher 1 and teacher 2, and he's asking us if we can conclude that there is a difference. I want the students to tell me which set of hypotheses we select, first, second, or third. Any suggestion? He said, can you conclude that there is a difference? So which one is it going to be, guys? Difference means what? Not equal. Y3. Why? Just curious to know, why did you decide on 3? Because 3 says less than, and 2 says greater than, and 1 says different from. So it has to be number 1. No, a difference doesn't mean less than. Yeah, it could be less than, it could be greater than. Since we don't know, we just use difference. That's a good point. So guys, you know, difference means this one right here. And this is where the claim is. The claim is in HA. So that's the first step. Let's write it down. I'm gonna go very slow with this one to make sure that you guys understand this. All right, let's verify that the conditions of the test are met. First of all, the samples are random. They are independent. How do I know they are independent? Because it's 2 different teachers, 2 different classrooms. They have nothing to do with each other. Now, he says that the populations are normally distributed, guys. Look, so we don't care about the sample size, whether it is less than 30 or more than 30. And actually, the sample size are less than 30, but because the population are normally distributed, we're in good shape. You see, guys, where he says here, population variances are not equal. That means when it comes to pooled on the calculator, you're gonna select no. That's what it means. Okay, let's run the test. Watch. Quit. Stat. Tests. Look, guys, it's number 4. We used number 3 last Monday, and now we're using number 4. Okay. X1 bar. 473. Let's do it together because you're going to be doing an activity later today on your own. S1, 39.7. N1, 8. X2 bar, 459. Don't be shy of asking questions, guys, because I wouldn't know what's going on the other side if you don't tell me, guys. I assume everything is good unless you tell me otherwise. N2 is 18. And now, guys, we need to choose the alternative sign. The alternative sign is not equal to. Watch. And look for pooled. We decided because it says population variances are not equal, pooled is no. So the p-value is going to be on both sides. Let's do it. It's a huge p-value. So T is 0.9224 and the p-value is 0.3792. See, guys, now we're doing the same thing as before. You reject HO or fail to reject HO. Step number 5, it's the same thing. So that to prove, you know, what I told you, how important chapter 7 was. 0.9224 p-value is 0.3792. And you know, guys, this is bigger than alpha. Alpha is 10%. So we failed to reject HO. Would the students tell me what's the conclusion? How do we write the conclusion here?
There's no evidence at the 0.1 level of significance to support the claim.
Thank you. That's it. Not difficult. To support the claim that there is a difference in the mean, that I'll write it down. There is a difference in the mean. I'm just copying it exactly. And the mean math test score for the students of the two teachers. For the students of the two teachers. There is not enough evidence. Look, guys, fail means not. Claim in HA means the word support. If the claim was in HO, you would say there is not enough evidence to reject the claim. So that means the claim probably is good. When we don't reject something, it means probably it's good. We're not sure, but probably it is. When we don't support something, we're just saying probably we need more evidence, to bring back more evidence in order for us to be able to support it. Okay, so that's the first question. Any questions here, guys, on the 5 steps? Okay, let's do one more. Let's come in next. There you go. A manufacturer claims that the call-in range in feet of its 2.4 gigahertz cordless telephone is greater than that of its leading competitor. Okay, guys, can you tell me which set of hypotheses you will be using? First, second, and third. The claim says they claim that their range is greater than that of their competitor. So would it be?
Second one.
I agree, because it says greater. If it's still not clear to you guys, please ask me, because that's very important to understand that. All you need, guys, put him in front of you and select one. You don't need to reinvent anything. Just select one of those. Okay, so this is the manufacturer. We'll call the manufacturer number 1. Usually whatever we begin talking about is number 1 and competitor is number 2. Okay, that's 1 and that's 2. So I agree. Just copy and paste, guys, from the handout. All right, you perform a study using 14 randomly select phones from the manufacturer. So N1 is 14. And 16 randomly selected similar phones from the competitor. So N2 is 16. The results from the manufacturer have a sample mean of 230, so X1 bar. And a standard deviation of 26, S1. You see, it doesn't say population standard deviation. That's why it's a t-test. And then he talks about the competitor, a sample mean of 216 with a standard deviation of 32 feet. Okay, at alpha equal 5%. Can you support the manufacturer claim? Assume population are normally distributed and the population variances are equal. What does it mean for us here, guys? When we go to pooled, we're gonna select what? Yes. Okay, conditions of the test. The samples are independent because it's two different brand names, so they are independent. Population are normally distributed, they said, and the samples are random. That's what it says in the language here. It says we selected random forms. So the conditions of, and sigma 1 and sigma 2 are unknown. So the conditions of the test, two sample t-test are met. Okay, let's perform the test. Ready? Bring your calculator. Stat. Tests. Two sample t-test. Okay, x1 bar. 230. Please correct me if I make a mistake. 26. And one is 14. X2 bar is 216. S2 is 32. N2 is 16. We need the alternative sign, guys, which is going to be selected now. And again, don't ignore pooled. We said we're going to use yes because it says population variances are equal. That's an assumption we make. And now, guys, let me just run. If you want to do a draw, your p-value is going to be on the right. Look how nice the normal curve is. Oh, so T is 1.303. And look at the p-value, 0.1017. It's big. Usually the p-value, the homework system will ask you to round it to 4 decimal places. So that's why it's nice to use the display. It will give it to you in 4 decimal places always. Well, alpha is 5%, guys. 10% is more than 5%. So we fail to reject HO. And guys, we fail to reject HO. Since the claim is in HA, we'll have the same conclusion as the previous exercise. There is not enough evidence to support the claim. At the 0.05 level of significance to support the manufacturer claim. And you can write the claim. And usually the claim, you know, just, it's right here. That the colon range, right here, guys. That the colon range of its 2.4 cordless telephone is greater than that of its leading cord. That there 2.4 gigahertz. Now there is 5.8 and nobody uses cordless phones anymore. So that's an old exercise. I might remove it next semester. Cordless telephone range is greater. We're not saying it is greater, we're saying we cannot support that than that of its competitor. So you notice here, guys, from the sample, the call-in range of the manufacturer on average is 230 feet, whereas 216 for the competitor, but yet we could not support the claim because there's so much variation here. There's so much variation, sample size. So even if the sample size show you something, guys, it doesn't mean that this is true for the entire population. You have to perform a hypothesis test to make a conclusion about the population. So in summary, guys, for section 2, perform a 2-sample t-test for the difference between two means, mu1 and mu2, with independent samples when sigma 1 and sigma 2 are unknown. Now I'm going to just flip the pages and I want to do a couple more exercises to review sections, as I told you, sections 8.1 and 8.2, but I want to do one more in section 8.2. So just one sec. This is the end of the handout, guys. I have some review exercises. So we're going to do question 3, which pertains to section 8.2. A real estate agent wishes to determine whether tax assessors and real estate appraisers agree on the value of homes. A random sample of the two groups appraised 10 homes. Is there significant difference in the values of the homes for each group? Let alpha equal 0.05. Assume that the data are normally distributed and that population variances are not equal. First of all, guys, can you tell me what would be the null and the alternative hypothesis?
Mr. Bazzi, is that question on the sheet that we printed out?
Yeah. You don't have it?
Give me one sec.
I'll email it again to you guys if you don't have it. I probably did not send you an updated one. It's toward probably the end. Yeah, I didn't number the pages. I forgot to number the pages here, so I can't tell you which page. So would a student tell me, guys, what would be the null and the alternative? It's asking, is there a significant difference? Can we agree, guys? We talked about difference before, that this is going to be it. So if you learn something out of those two exercises we did, you know that difference means not equal to. Okay, guys, 2-sample t-test. And you should be grateful, guys, when the problem is laid out like this. He already give you the table. He labeled everything. All you need, guys, is just to enter the data into the calculator. So let's do that. Tests. This is the real statistics, guys, that you're learning. This is what the course is about. That's the core of the course. Hypothesis testing. X1 bar is 83,256. That's the assessed value by real estate. S1 is 3,256. N1, 10 homes. X2 bar, guys, this is the tax assessors. I suspect the tax assessors always will try to do more higher value because they want to charge us more taxes. S2 2341. N2 is 10 and not equal to. And for pooled, guys, it says assume population variances are not equal. So you agree with me that we're going to use no for pooled. See, population variances are not equal. Here you go. And if you like to do a draw, I like that. I like you to see the p-value in action and visualize it. It's good to visualize the p-value. The p-value, it has two tails here, but we barely can see anything. That means the p-value is very small, guys. So T is negative 4.0201. And look at the p-value, guys. Barely anything. That means you reject HO, less than alpha. What was alpha here? 0.05. All right, and let me continue. So reject HO, of course. Once the p-value is very small, you have a strong evidence against HO, guys. You just reject HO. Reject HO and you favor HA now. So there is enough evidence at the 0.05 level of significance to support the claim. As I told you, tax assessors usually, try to give a different value from the real estate because they want to charge more taxes to support the claim that there is a significant difference. There is a difference in the values of home for each group. In the values of homes of each group. All right. So that's a question 3 to sample t-test. This time when you reject HO, you start with there is enough evidence. Why did I use the word support? Because the claim is in HA. So remember, guys, when the claim is HA, include the word support. When the claim is in HO, include the word reject. If the p-value is less than alpha, start with there is enough evidence. If the p-value is more than alpha, start with there is not enough evidence. I mean, it's not going to change, guys. It's exactly what I'm saying right now. Okay, let's do the other one. Question 4. You're ready for the next question. A research suggests that male nurses earn more than female nurses. So that's the claim, that male nurses earn more than female nurses. A survey of 14 male nurses, so N2 is 14. Now you ask me, why did I put N2 here? Because he called males, make him number 2. So I have to comply. And 22 female nurses reports these data. So the females on average make 23,750. It's a lot more, guys. So this data is not true. I don't want to discourage you from becoming nurses if you want to. I know nurses make a lot more than that. And standard deviation is 250. Maybe this is in 4 months or 5 months. And one is 22. And this is the males on average, they make 23,900 with a standard deviation of 300. Is there enough evidence to support the claim that male nurses earn more than female nurses? Use alpha equals 0.05. Assume the data are from normally distributed population and that population variances are not equal. Meaning here, guys, put a note for yourself. For pooled, when it comes to the test on the calculator, it's a no. Okay, who will help me state HO and HA here? So this is a two sample t-test again. Okay, so we have X1 bar, S1, N1, X2 bar, S2, N2, which is 14, and mu1 is less than mu2. And again, because that wasn't in the recording before, we put mu1 less than mu2 because we started with the females were numbered as 1. So if males earn more than females, that means females earn less than males, and females were the first set. So we have to start with the first set always. So mu1 is less than mu2. And draw. You will see a p-value on the left, guys. The p-value is the area to the left of the test statistic. There you go. So t is negative 1.558. And the p-value, guys, is 0.0661. And my alpha is 5%, guys. You agree with me that 0.06 is bigger than alpha. So we fail to reject HO. And it was obvious, guys. The males don't seem to earn on average more. I mean, they seem to be very much the same, as you can look here. So I don't think we're going to support this claim. There is not enough evidence at the 0.0. You can put here 5% or 0.05. It doesn't matter. Level of significance. The 5% here is the maximum allowable probability of making a type 1 error. So there's always a chance in statistics of making type 1 or type 2 errors, guys. You could reject HO when it is true. You could make this mistake. You could fail to reject HO when it is false. That's another mistake. It does happen in statistics. And so there's not enough evidence at the 0.05 level of significance to support the claim that male nurses earn more than female nurses. Or you can say female nurses earn less than male nurses, the same statement. I mean, you say 8 is larger than 6, guys. 8 is more than 6. If you put 6 first, you say 6 is less than 8. It's the same statement, but just reworded. Okay, so that is number 4. And I'm going to go and do number 2, just to remind you guys of section 8.1. How we did 8.1. Survey found that the average hotel room in New Orleans is $88.50. And the average hotel home room rate in Phoenix is $84.75. Assume that the data were obtained from 2 samples of 55 hotels each, and that the population standard deviation were, you see, he gives you population standard deviation, sigma 1 and sigma 2. Respectively, At alpha equal 5%, can it be concluded that the average hotel room in New Orleans cost more than in Phoenix? So New Orleans, and that's Phoenix. So he says X1 bar is 88.50. Sigma 1 is 560. And N1, he says 55 hotels. For Phoenix, guys, X2 bar is 84.75 cents. Sigma 2 is $4.83. And N2 again is 55 hotels. And he wants to do the study at alpha equals 0.05. You know, guys, this is a 2-sample Z-test. And why a Z-test? Because he gives you population standard deviation, sigma 1 and sigma 2. Another hint for you guys to know that it is a Z-test. If it doesn't talk about assume population variances are equal or not equal, that means pool doesn't exist in this problem, that it's likely to be a Z-test, not a T-test. So let's do this one. Number 2. All right, let's do this. So get your calculator ready. And let's do this. That with this, we'll have done a very good review of the 2 sections here, 8.1 and 8.2. So let me get the calculator. 2-sample Z-test. Okay, sigma 1. He wants sigma 1, guys, 560. Then he wants sigma 2, 483. Then he wants X1 bar, 88.50 cents. Oops. Oh, I see. Then N1, 55 hotels. X2 bar, 84.75. Be careful as you do the data entry. I'll look carefully. I will review it twice, guys, just to make sure. 4.83 for the standard deviation. N2 is 55. Oops, sorry. And then we want to check that mu1. Okay, he says, can it be concluded that the average hotel room in New Orleans cost more than Phoenix? So let's state the null and the alternative hypothesis. We should have done them first before we went to the calculator. More than, you guys agree with me, it's a greater than. So that's a claim. You can see it's mainly you're seeing today more than, less than, different from, so you should get used to that one. That's the claim. So let me just select that one. And let's do a draw. So your p-value will be on the right this time. And it didn't show any p-value, that means it's almost 0. So Z is 3.76. And look at the p-value. I'm gonna just write down what the calculator did, but don't put that as an answer, even when you do your homework online. E minus 4 means you have to move the decimal point 4 digits to the left. So look, this is the decimal point. So move it. Okay, let me put the 1 dot. If I wanna move it, I need 1, 2, 3, 4, and put it here. So it's gonna be 0.001. That is the p-value. and which is less than alpha, of course. So reject HO. Okay, there is. When the p-value is very small, guys, that's a very, very strong evidence against HO and in support of HA. There is enough evidence at the 0.05 level of significance. And this is how all those vaccine companies did their research and submitted to FDA through a hypothesis test. But I think the alpha that they use is 0.01. So alpha was very small one. It's only 1% chance of making a type 1 error. There is enough evidence at the 0.05 level of significance to support the claim that vacationing in New Orleans cost more than vacationing in Phoenix. All right, that concludes